Should be
Got
good.
it.
Should be on.
Okay.
Oh, got it. Hey, everybody.
Excellent.
Welcome aboard, Sky viewers, watchers, telescope lovers. It's our 31st program that we do on Monday mornings. Am I being heard? Is everybody together?
I can hear you fine.
Yeah.
All right. Well, welcome to the SBAU Hour, the Astro Hour, we call it, for astronomy, because that's pretty much the name of our club here in Santa Barbara, California, Santa Barbara Astronomical Unit, SBAU.org. I am very proud and happy to be part of the crew on the board. And we got some real bright minds that we get to talk to. I'm not one of them. I'm just the question guy and also vice president. But this is episode 31 for Monday, the 27th of September through October 1st. And gentlemen, let me introduce you, and then I'm going to hit you with something that you may or may not know real quick. Breaking news right now happening. Maybe you know what I'm talking about. Jerry Wilson, president, 3 seasons, 4.
Hello.
How you doing, Jerry? Thank you.
Good.
Wife is Pat Forgy. Our incredible webmaster, my good friend, former president, technical wizard there, Tom Totten.
Always looking up.
Controlling. He's also married to a lovely artiste named Suzanne. And until we're joined by Bruce Murdoch, we'll introduce him when he gets on board. It's Tom Whittemore.
Hi, morning, everybody.
Tom is back and got a full set of eyes, or do you have a loaner from that damn? It's terrible when they got to work on your car and they give you a loaner. The same thing with eye surgery. We're not joined by Chuck today because he's out getting his Jetsons car. Jerry has been speeding around in his, and you don't hear a lot of noise, but I guess they got a fake noise in them, don't they, to take care of the blind people walking?
When you back up.
When you back up, yeah, our neighbor has a Tesla, and I could hear it makes these funny, almost siren-like sounds as you back up.
Whining sound, yeah.
Yeah.
It's not that beep thing you hear from a big truck.
No,
making a delivery?
it's like whoa, kind of like that.
Yeah.
Well, listen, we're going to talk about several things today. I might wait till Bruce gets on board to talk about.
I am, but I don't. Can you hear me?
I hear you now, Bruce.
We just can't see his face.
Somehow I said join with video, but it just has this graphic of a person.
Well, I'll leave it up to you, Bruce. You can try again to get your photo with your beard on screen, or we can just talk to you as a voice and you can tell us what you've been doing with the Serpentine Ridge on the moon when we get to that.
Tom Totten and I have had a back and forth on that.
Yes,
Anyway, Tom, can you set it up so that I have video?
I don't see anything. I can stop your video. That's all I have available.
Bruce, that's on your
Oh,
end.
now, hold on. Something changed. Now it says ask to start video. So I'm going to click on that.
Good.
That's on my screen.
There we go.
Second fire.
Maybe that.
Bruce Murdoch, ladies and gentlemen.
No change.
There we
There
go.
you are.
All right.
All right,
Stand
welcome
corrected.
aboard. Get you centered there. Bruce is a longtime active member, also president of the Santa Barbara Theater Organ Society. His wife is Bonnie. Tom Whittemore used to teach. I guess you retired from Westmont, Tom?
Yeah.
Again,
Mhm.
everything doing fine. Your wife, Maureen.
Mhm.
And other than the asteroids, we got a couple asteroids we may be talking about in the program later on. We talk about all the good stuff that's happening. Are you aware of what's happening right now, possibly at Vandenberg Space Force Base at this very moment?
Oh, that's right. That's right.
Landsat 9, which has been around for 50 years, and it happens to be the 2000th launch from Vandenberg, which is now known as VSFB, and it's supposed to launch at 11 a.m., which is just past that hour right now. What?
I doubt that we could see it though because of the overcast.
Well, I'm
Yeah,
sure
I can't see it.
It's
here.
solid white here.
Yes,
None of
in
you-
here.
None of you have a, well, yeah, that's true. You can't see a thing anyway. So it's going up in space, and we'll see if it gets some great pictures of the changing landscape down here, much of which is changing due to climate change, as you know. We got talking points sent to all of us this week about the moon, which is on its waning side. It's less than half, second quarter, third quarter? How does that work?
Last quarter.
Last quarter, okay. And then it flips over in about a week and a half, I guess. We'll talk about a couple of important asteroids. And also compare our moon to a moon that's even bigger. And I guess we're going to be sending something there called it's a balloon, the Titan Saturn system missile or mission.
Mission.
Sent that. Do you know much? Can we talk about that later?
Sure.
Mr. President?
Yeah.
All right. Let me read you what he told us about the last quarter moon with a picture. You can call up anytime, I guess, Tom. It's called the Serpentine Ridge. You know, I've not heard of this. I know of the Mares and Tranquility Base and Basin and all that. Dorsa Smirnov. I'll drink to that. Winds 200 miles across, also known as the Popov and Absolute. I'm not a drinker, but I know a few brand names. So here it comes.
Those are jokes for the drinking class, huh?
That's true,
Yeah.
right? The Sea of Serenity. Moon starts to wane and shrink down. The sun is now setting. You're going to have to explain this. We're going to have to get into this. And I guess you got pictures too, Bruce Murdoch?
I sent some to Tom and to Jerry. I sent some to the whole list.
Yeah.
Well, all I did, I took a picture of the moon when it was full back, I think in 2013, before the LED streetlights.
All right.
And you can zoom in on that and see things.
Is this the one you took?
Yes.
Okay, so we see the same side of the moon, and whether it's quarter or not, or full, in this case, full. So it's up there above one of those seas. It is a sea, I guess.
Yeah.
And it involved lava and reverse, let's see.
Difficult
lighting.
to pick out the ridge on that.
Okay, can you find it? I see your
Tom?
cursor.
Not that clear, but
Yeah.
Well, it's only 240,000 miles away.
Yeah. And it's lit face on. These ridges and irregularities in the seas are best viewed at very oblique lighting, like the last quarter. And this is close to the terminator, so you get a stronger shadow effect, illuminated on one side and a dark on the other. And this is what's known as a pressure ridge, where two plates come together and they crunch up where they meet. You get these a lot on ice flows in the Arctic, where two sheets of ice have run into each other, and then you get a ridge built up where they collide with each other. So this
And they've
was
grown a lot. They've
yeah,
grown
they
a lot
grow.
as they grow.
Yeah.
I've been there.
So this one probably didn't grow due to the no atmosphere, but it does indicate that it at least had a solid surface at one time that moved against another solid crust. There's a number of these things all over the moon and some craters and stuff. Especially, I think the crater Ptolemaeus has a bunch of this stuff.
hey, Jerry, I want to show you one that's in that Poseidon's crater there. Let me show
Yeah.
you this one. I'll stop the
Posidonius.
share. It's
Posidonius.
pretty amazing appearance. And here it is right here. And you can see a bunch of canyons and things here, but this is a weird one over here on the left-hand side of the crater. And you can see how it wiggles around,
Mhm.
goes all the way around the
Now
crater.
that's not a pressure ridge. That's a collapsed lava tube.
It's
Really? At the
very,
bottom?
very.
Crater?
It's something
Well,
that
that's-
has sunk in. It was full and then it caved in. But this does not rise above the surface. So this
Right.
could result from plates moving apart, and on the other end of the plate, it ran into something. It's a crack. Somehow it would not structurally support the surface, and the surface collapsed.
Okay. When did it stop tectonicking on the moon? That had to have been
Oh.
billions of years ago, right?
This what we're looking at on the surface. The surface is basically cold, and so it's stopped its tectonic stuff. It does not have active plates like we do on Earth.
Okay, but lava is involved here. There's no more lava on the moon or under the surface, is there?
I don't know about under. There might be magma underneath. I don't know
Really?
about that. But there's
Okay.
none that we've been able to spot on the surface.
Well,
No active volcanoes.
here's the part of your notes I didn't understand. As the moon starts to wane, the sun is now setting over the Sea of Serenity.
Yeah.
This paints the lunar landscape with reverse lighting, sunlight coming from the opposite direction as it does when the moon is waxing.
Yeah.
You lost me on that.
Okay. That's when the moon is waxing, you're at first quarter, and the sun is illuminating from the other side. So it's like morning sun. And then here we're looking at evening sun. So it's coming the other way. So it puts the shadows on the other side of the feature. So it gives you a different look at the same thing. People that do this, that look at the moon a lot, are more familiar with the first quarter, because you can see that in the evening. To see the last quarter high in the sky, you have to be up just before dawn. The last quarter moon rises at midnight, and it's directly overhead when the sun comes up.
Tom Whittemore, you ever photograph that? Are you aware much of this topic?
Tom is gone, I think.
Oh, we lost him again.
Ooh, well, okay. Unique chance to view familiar features looking almost alien. So in other words, what you're saying, Mr. President, is that we see one quarter of the moon on one side of the Earth, and on the other side, we see the other quarter?
It's not the other side of the Earth so much. It's because we're always here. We always look at the same, from the same place on the Earth. But the sun is shining. In this case, it's shining from the left to the right, because you can see the right side of the picture is dark. That's the night side of the planet, of the moon. On first quarter, it's the other way around. The right side is bright and the left side would be dark. It's shining on the other side of the pressure ridge.
Okay, but one of the things I learned from you guys weeks ago is that the best time to look at the moon in a telescope is with a crescent. Does this feature ever get inside a crescent? It's not on the edges, is it, of the face?
Well, it's just like, it's the best place to look on the moon for features is at the terminator. And you see in the picture Tom has up now, on the upper right with the waxing crescent, you can see that the terminator is this curved line. And then later at first quarter, it's a straight line up here. And then on waxing gibbous, it's now this bulging line. The only time, and wherever you are near the terminator, you get strong shadows, and that shows you the contrast on the surface of the moon. The only time you don't get much features is at the full moon, because the sun is shining straight down on everything. So there's really no shadows.
Okay.
And the shadows are what shows you detail.
Okay, but what
here's that Poseidon crater right on the waxing gibbous here. You can right up here.
Yeah.
On the terminator.
Tom, it looks like Poseidon, but it's not. It's a totally different word.
Yeah,
Posidonius.
Posidonius and his orchestra.
Well, Jerry had the link to an article where it said they Latinized all the different features on the moon back in the 70s or something.
Okay, well, is there some Russian involved in naming this, named Smirnov, for whom the podcast
well, I don't think they named it, but they got it named after them.
Dorsa Smirnov.
Now, if you want to see a lot of Russian names on the moon, look at pictures of the backside, because they were the first to send a probe past the moon and look back and see the backside of the moon. So they got naming rights to a lot of the structures back there.
And they don't have a lot of seas, also known as mares.
The biggest sea, I think, is this little dark area called Sokolsky.
Oh, is that on the screen right now?
No, it's on the backside of the moon.
Posidonius is a crater?
Yeah, right there on the upper top of the picture there.
All right, well, then that doesn't have anything to do with lava, past or present.
Well, no, it had lava in it too. That's the feature that Tom showed earlier, where it was very close up with the collapsed lava tube in it, the stitching pattern that went around the edge. It was the opposite of a pressure ridge.
Okay, but it wasn't a strike from an asteroid or a comet. It came up from below like a volcano on our planet.
These were something big hit the moon where these seas are. And it either broke through a crust and hit a magma chamber, which then filled up a sea of magma, or the kinetic energy of the impact was big enough that it melted everything it touched, and that produced the lava. But whatever it was a big sea of liquid afterwards, and then it started cooling from the outside to the inside.
In the middle of that picture, it says Dorsa Smirnov, and the arrow points right. What is it pointing to? The mountains over there on the right side?
No, that ridge, that rill.
You mean there's a sort of a line that borders something?
Yeah, it's what Tom is running the cursor up and down.
Oh, that's a ridge?
Yeah, it's a ridge.
So we're looking at kind of a mountain range,
Yeah, exactly. But it's a low one. It's called a pressure ridge.
and it's
I sent you a
also-
picture of, oh, go ahead. I sent you a picture of when I was in the Arctic in May of 1969, where we were doing under ice acoustic research. You could see the pressure ridges.
under the Atlantic. Okay,
No, we
so-
were 300 miles from the North Pole, 850 miles from the nearest land.
But would it be
Yeah.
safe to say that Dorsa Smirnov is part of that big sea?
Yeah. Oh, yeah. It's a wrinkle in the sea.
Oh, and so, okay, I got it. And you guys focus on this, and you can actually see that ridge.
Oh, yes. That's an easy thing to see in the amateur telescopes. Now, let me tell you that this feature of pressure ridges like this, like we talked earlier, it happens in ice,
There's
as
your
you're
picture.
seeing there.
Yeah.
These are where ice things jam together, and then at the edge, they force themselves up. The ice
Oh.
crunches up, it lifts up. So that's exactly what this Dorsa Smirnov is a pressure ridge, but in lava. Now, this also happens microscopically, and it's a good way to screw up filters, multi-coated layers on lenses, because when you deposit the materials, usually oxides, on the lens, when you've evaporated and it comes down as a vapor, and then when the vapor hits the surface of the lens, if the lens isn't at the right temperature, the atoms freeze right where they land. You want the temperature of the lens to be about 2/3 the melting point of the stuff you're depositing, so that it has a chance to move around on the surface and get happy with its molecular bonding. But if you then suddenly heat up the surface to get ready for the next layer, you can cause pressure ridges in the first layer by the expansion of I'm going the other way. When you cool it down, the lens will shrink, and then these pressure ridges can form, and they muck up your interference pattern. That is how the multi-layer coating works. So multi-layer coatings are a major breakthrough in being able to have a good high throughput in an optical system. But if you don't do it right, it's an opportunity to really screw things up. Because you get these things like these pressure ridges, you get those in the microcosm on the layers as you deposit them.
Okay, I know we're not looking at where Neil Armstrong landed with Buzz
No.
Aldrin, but would that be called Dorsa Tranquility?
Dorsa what?
Tranquility
No.
Base. That's
No, I
another.
don't think Dorsa had anything to do with Tranquility Base.
Well, I understand that, but is Dorsa another word for Mare or Sea
No.
of?
Dorsa's the name of this person.
Oh, the whole name there, Dorsa Smirnov.
Yeah.
Gotcha. Do any of the other seas on this side, since we got all the mares, the big wide flat
Uh-huh.
plains, have a ridge like that?
Yes, many of
They
them
do.
do.
Oh,
And many of the larger craters that are filled with lava have it too.
and obviously the word serpentine, I guess, applies to the way it snakes across that sucker there.
Yeah.
Look out for the
Yes.
snake. But it was triggered by Posidonius on the top.
No, probably had nothing to do with that. Posidonius is a crater that came later.
Oh, okay. And how long ago are we talking active lava on the surface of our moon?
I don't recall.
No
it's-
theories?
I guess we had two major bombardment periods on the moon. And they were both billions of years ago, soon after the moon formed, and then after a respite, another bombardment period. But I really am not up to speed on the statistics for those. But you see the arrow from Dorsa Smirnov. See, it points to the ridge, but if you continue that over, you see a half of a crater that's flooded with lava. That crater was there before this sea was formed, because the sea flowed into it and filled it up.
The
And
sea,
Jerry, I want to mention on the name Dorsa that Dorsa actually means ridge.
Oh, does
And
it?
The
Oh.
Soviet geologist's name was Sergei Sigridjev Smirnov. So his
Oh,
name
yeah,
was
that guy.
just as just to have just his last name with Dorsa means ridge.
Okay, Ridge. Okay, Smirnov Ridge.
so if Armstrong and Aldrin had landed there, they would have said, Houston, Serpentine base here.
Yeah,
Okay, Serpentine is the whole big wide flat
it's the shape of the feature.
the farmland of the moon, the
Yeah.
hinterland. Wow. How many Mares? Is that an American word only? M-A-R-E-S?
No, that's an Italian word.
Mare. Okay.
Yeah, it means sea.
Spelled the same as female horse, but pronounced totally different.
Yeah, it is.
And how many are there? Do they have those named? They're on our side of the moon, aren't they? The side that faces us.
There's about a dozen, I think.
But this is the only one that has a ridge across it.
No, they almost all of them have some kind of ridge somewhere or a collapsed lava tube. They all have a lot of features like this.
And I'll just bet you these early launches, they try to miss them, right? They don't want to land on or near it.
Oh, for landing, yeah. They landed near Hadley Rill on one of the missions, and that was a collapsed feature.
And what is a rill?
A rill is just a line like a serpentine line.
Oh,
It's a
okay.
wrinkle.
Yeah.
All
So
right.
Baron, you're asking about how many Mares there are. Here's a list of them. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So they're all over the moon there, these different
Yeah.
spots.
Yeah, I heard, we've all heard that the moon would be a lot brighter if it wasn't basically dusty gray, and it looks gray in that picture. But boy, on a bright moonlit night, if it was like one of the moons around Saturn or Jupiter, boy, we wouldn't need the sun. It'd be perfect. There we
That'd
are.
be
The
pretty
average-
dim.
The average reflectance of the moon is 16%.
Yeah.
Aha.
It's dark.
Well, Bruce, isn't 16%, is that higher than asphalt?
It's about the same.
About the same?
Yeah.
Wow. Great stuff. I never knew about this.
Now, technically, the technical term for reflectance is
Albedo. How do you say it?
Albedo.
Albedo. Yeah.
Hmm. Fantastic. Well, yeah, who has pictures of it other than Bruce? Was that wasn't a picture of the
We have a
rill?
picture of the moon which captured it.
Okay.
I have a picture of the moon with the International Space Station going across it on
Oh,
YouTube.
that's right. Yes,
Yeah.
yes.
Those are pretty interesting pictures. I guess those are fairly hard to get.
I had to go to Montecito a long ways.
Yeah. Oh, you took it yourself?
Yeah.
Oh, I didn't know that. Okay. Do you have it? Let's see it.
It's right here somewhere on YouTube. Let's see where we got things.
Well, why don't you
What
look
scope did you use?
I used the C8.
Oh, okay. With a Barlow?
No, I didn't have a Barlow. I think I might have used an f6.3 though, which made it a little bit narrow. Let's see, where did it go? It's a while back. Looking on our YouTube page, and there he goes, right here. So if I click on this, I can hold on for a second. I'm setting it up for a second.
Dealing with technology has a mind of its own.
All right, hold on. Let's see. Stop share. And share the new screen here. And then I have to hit recycle. So no, back.
You don't want that one.
There it is, going across. Replay. Here, watch it. Can you see it?
Yeah.
You took that
No,
picture?
you don't.
Doesn't want to stay
Yeah.
on there.
Can you see it?
It's moving pretty fast.
Yeah, it was only half a second, a little less than a second, I think.
Yeah.
Oh, this
Okay.
is out of a video?
Yeah.
Yeah.
It is. It's a short video clip.
Okay.
Right. And those are actual frames of it going across.
Uh-huh.
So each little, it kind of really stops.
Oh, the
It's
ISS.
like
Okay,
maybe
now-
35 frames or something. Yeah. You can
Good
actually
job.
make it out.
Well,
What,
Thank you.
what exposure time did you set it at?
Well, it's actually just on the video for my digital camera, and just let it roll.
Okay.
So, auto exposure.
It's probably pretty short because the moon is bright. Like the
Mhm.
picture that I took was 1/800th of a second.
Yeah, I don't think
At,
they identify that on my video, what the exposures are for doing video.
Can I ask
Anyway.
about a recent exchange that involved what's called the Lunar Reconnaissance Orbiter?
Yeah.
Is that available for the folks?
Yes.
I don't want to give that big, long blue link of
All,
4,000.
virtually all the satellite pictures that are taken by satellites are available to people. It's public domain because we paid for the satellites in America.
But can the people that did not get the email from Tom, the webmaster, talking about the Lunar Reconnaissance Orbiter?
Uh-huh.
It's a camera that goes around. Is it ours or is it some other?
No, it's
company?
ours.
It's ours.
Yeah.
Is there a simple website or can they get it all by going to SBAU.org, Tom?
If you just look up Lunar Reconnaissance Orbiter, you'll find a website like we're looking at right now that shows all the images of the moon. Right. So right now I'm zooming out. So it says we're now 1 million kilometers above the moon. Is that right? That's amazing. 1 million. And then you can click on a spot to get the maybe recenter things a little bit better. So it's got
These
the
are all
front of the
collages
moon.
then. Yeah.
It's got the front of the moon and the back of the moon. You know, you can see everything.
That's not
Up-
what we're
up
looking at,
close.
is it? We're not looking through the camera of the lunar.
Yeah, we are.
Really?
Well, no, these are pictures that were taken and then returned to Earth, and you're looking at that library of pictures.
Oh, I
But
see.
it's not a real-time picture of the moon.
Now, these are collages, are they not? Because the orbiter
Yes.
is only 50 kilometers above the moon.
That's right. Yes,
But
they're mosaics.
They don't
Mosaics,
have
either way, yeah.
They don't have any moving
Oh,
videos.
stop there. Traverse of the Apollo landing sites. That's
if we
near
can-
Hadley Ridge, I think. That big black line going through there.
Let's see what it shows here. Lunar. Oh, these are new craters. Apollo landing sites. Apollo 11.
Uh-huh.
So
Yeah, it wasn't
temperature-
Apollo 11 that did the Hadley Reel.
Oh, it's a different.
Really?
Yeah, it was Apollo 13.
Yeah, right.
Let's see the one. Let's see. Here, let's do one with the rover. See if they show it. The traverse. They're saying.
Oh, yeah, you can see it in Apollo 16. You
Yeah.
can see the tracks.
Let's see. Zoomable traverse. Oh, it doesn't show. Oh, there it goes. They're showing it on top there.
Wow.
Different stations. They called it 1, 2. I don't know where it happened to 3, 4, 5, 6. It's strange. So yeah. Back out.
Which is the one where they had to call AAA.
I got to tell you, President Jerry, if that gentleman that sold you and Chuck new cars gets his way, he'll be the first colony on the moon, the way he's going.
Yeah, I understand our cars will work on the moon.
You'll need a dummy at the wheel.
Maybe not, because they need cooling for the batteries, and that's exchange to the air,
Yeah, that's right.
liquid to air. But
Liquid air. I can't think of a cooler.
no, they
place.
run a liquid through the batteries, but that liquid gets heated and it goes through a radiator, and the heat gets transferred to the air. There's no air on the moon.
So how would you cool something on the moon?
You can radiatively cool
Radiation.
it.
Can you radiate
Pardon?
stuff
Yeah.
on the moon with no
So
atmosphere?
just put some metal fins out into a shady spot on the moon.
Yeah, basically.
The Lunar Rover it's an electric vehicle. We built that here in Goleta at General Motors, and even though the motor controller was 93% efficient, there's a 2 horsepower DC motor in the hub of each of the 4 wheels. You could run we couldn't radiate that amount of heat away, so there was a big wax cake on top of the control electronics, or actually a box, and we used the latent heat of fusion to absorb that heat. We melted the wax, and they could run the rover for about 8 hours, for about 2 hours, and then they had to let it cool for 8 hours to radiate that heat out to space.
Wow.
If you make a heat pipe, and we cool detectors in satellites that same way, is that you put the detector on a cold finger, and then you have a heat pipe that takes the heat from that cold finger out to the side of the satellite, And then there's a plate there that projects that heat out, radiates the heat out into the 4 Kelvin background of deep space. So you have to be careful that it's always pointed at deep space, because that is so cold. It basically can absorb an infinite amount of heat compared to your satellite.
4 Kelvin. How does 4 Kelvin translate into Fahrenheit and Celsius? The same?
It's 269 degrees below zero.
Yeah.
Celsius.
Or minus 450 probably Fahrenheit.
Yeah.
Well, you have to multiply by 9/5 to get it into Fahrenheit.
Oh, is that right?
So 4 times.
There's a formula for it. I should learn that.
They're easy. You get them in high school.
Yeah. Well,
Degrees C is 9/5. Degrees F is 9/5 times C plus 32.
Wow, and his orchestra. Question of Mr. President, since you're the first, and there'll soon be another, and then Tom, I think, is going to get a Ford electric car, right?
Well, I'm looking at the Ford F-150 truck electric Lightning. Yeah.
All right, here's my question.
Lightning, that's a good name for it.
Do they give you, like you get a spare tire or a jack or things that come with it? Do they give you a connection for your garage to plug it in? Or do you have to look for their charging stations? Do you get your own charging
You call your electrician and you come over. You call your electrician and he comes over and he installs a Tesla charging station, either in your garage or on the side of your garage. Ours is on the side of the garage.
Okay, well, there's got to be
when the car gets down to about 20%, we plug it in and it takes about 7 hours to charge. We do it after 9 o'clock like they ask, so it doesn't overstress the grid.
Okay, but the car comes with the plug, I'm sure, the mail, right? That rolls up in their trunk or whatever.
They have a converter, because not every charging station has the same plug as the Tesla. So you have a converter that'll match other plugs for other cars and go in. But for charging it, you need to get that from an electrician, the cord and the plug and the power pack that converts it.
This is where our government could do something useful. You know, all the electric outlets in the United States are standardized. You don't have to, it doesn't matter who makes them, Hubble or whatever. They should standardize the connectors that are on electric cars so that it doesn't matter what car you have or where you find yourself, you've got a plug to go into it.
Yeah, I think that'll happen.
Is it pretty much standard on all computer brands? The same plugs work?
Well,
USB?
We all use USB, A, B, C, A, B, or C.
Okay. And
they're backwards compatible.
Yeah.
Of course, Bruce's headphones have a mini phone plug, which is what, 1/8 of an inch across, not a 1/4 inch.
Right, it's an 1/8 of an inch, right?
Gentlemen, shall we compare moons? Ours versus theirs. I didn't know this until I saw it, but I'm going to ask you, which moon is bigger, ours or Saturn's Titan?
Titan.
Really?
Titan used to be considered the biggest moon in the solar system just by looking at it from telescopes from Earth. But now we know the biggest actual moon is Ganymede, because what we were looking at before was Titan's atmosphere. And if you take away Titan's atmosphere, the actual moon is slightly smaller than Ganymede, but it's a close horse race.
Okay.
This is an illustration to scale of the Earth, our moon, and the moon Titan.
Wow. Makes you wonder, what does it take to have an atmosphere? I mean, why doesn't our moon have something around
Gravity. Takes gravity.
Okay, so it's thicker, heavier.
Yeah, the moon sucks. So the reason that's yellow-orange is because it's nitrous oxide compounds in the atmosphere. The atmosphere is basically smog.
Nitrous, not carbon.
No, nitrous.
Okay.
There's hydrocarbons on the surface, but they're as liquids.
Well, if it's methane, it turns into a gas and then rains.
It's methane and ethane, but since we heard that English postdoc from LCO give us a lecture on it, now I call it methane and ethane. So if you'll scroll down a few pictures, there's a picture of the North Polar region of keep going, of the Titan with keep going.
It's even beyond this.
No, there. This is mappings or regions of the, by radar. These are regions of the North Pole of Titan. You can see the North Pole is up there, that region where the lines end in a little circle. These bluish black features are lakes of hydrocarbons, methane and ethane, or methane and ethane.
Okay, which are giant convoluted molecules, aren't they? Like,
No, they're just simple molecules. They're organic molecules.
well, isn't carbon part of that? Hydrocarbon would.
Hydrocarbons, hydrogen, carbon, oxygen.
CH4 and C2H6, right?
Yeah, they're not real long chain organic molecules like peptides and proteins and stuff.
You know,
Okay.
Ron, octane for a gasoline engine, that has 8 carbon atoms. They call it octane. So then 7 is heptane, 6 is what is 6 called? Sextane? No.
Cystine,
Hexane.
And then pentane, and then what's 4? 4
quadrane,
carbon.
triquine.
Of course, propane is 3.
I don't think anyone
and-
uses those. That's why we don't hear about them.
Yeah, maybe so. So those names come from the number of carbon atoms in them, and they're just small molecules with hydrogen attached. You know, hydrogen's
Uh-huh.
a tiny little atom.
Okay, but we have made many ourselves, have we not? We have butane, propane,
Yeah,
polyethylene, and that's ene. Ene and
But-
ane are
Well, that's a
different.
very long chain.
yeah.
Yeah. Well, they're all long. They're all
No. These are real simple little molecules.
really.
Yep.
That's the,
CH4.
yeah, methane is
Petroleum?
CH4, 1
Okay.
carbon and 4 hydrogens.
I know carbon monoxide is pretty small,
Yep.
1 each.
Yeah, CO.
And if they were separated instead of together in the molecules of methane, if they were separated, they would ignite, wouldn't they? Oxygen would have to combine.
If you had any oxygen in there and you had a match, you could burn the atmosphere of Titan. Yes.
But it doesn't happen, or did it happen? Maybe it's already happened. That's how we got the
Yeah,
methane.
that's right. And Mars did the same thing. Mars is a lot of iron combined with oxygen. That's why it's red. It's basically rust. And all the iron has been oxidized. So
Wow.
there's lots of oxygen on Mars. If you want to break the iron oxide bond, you can generate a lot of oxygen.
Oxygen, I heard, was the most prevalent element on Earth. Thank God. Am I right on that? I read it somewhere. I heard it. There's more.
I haven't
oxygen-
heard that. I know the dominant element on the surface of the Earth is silicon. And on the Earth, I thought it was iron on the whole Earth volume throughout, but don't quote me on that. I'm just trying to use my senior moment riddled memory.
Well, a practical mind would think that all the heavy elements, your lead, your gold, would just go to the center, and it's probably all
Yeah.
down there.
That's right. We're a differentiated planet. We were molten for a long time and all the heavy stuff sank.
And luckily, some of it stayed on the surface and made
Well,
us
I think
millionaires.
the stuff on the surface is from impacts that followed the differentiation period.
Oh, no kidding.
So if you look down one more picture, you can see the orbits of Saturn's moons with the red line, the red circle, go up a little bit, with the red circle showing Titan's orbit. So it's slightly,
Yeah.
they're not
Slightly-
exactly the same. So they look circular to me, both of them. But I think the outer green one is offset and Titan is
Oh.
more centered on Saturn.
The one just past it, just around it,
Yeah.
immediately outside of it. What is that? Which moon is that?
The
Enceladus?
let's see, the caption, the moon's outside the orbit from the outside to the inside, Iapetus, so it's Hyperion. The
Oh,
one just outside the red one is Hyperion.
right. And
Inside going in there, Rhea, Dione, Tethys, Enceladus, and Mimas.
that's how it's pronounced. And those are all Greek. That's Chuck would know if he were on board.
They're Greek to all of us because they are Greek.
I was going to say that. That
Oh.
was
We
tacky.
minds think alike. Next picture down shows a model of the interior of Titan.
Yeah, let's look at that. There you go. Wow. All right. You want to explain what's going on here on the layers?
Well, you
Wow.
can see the atmosphere, lower atmosphere, thick Folian haze, upper atmosphere. The haze is the smog layer. The surface is this combination of frozen ice and, I don't know, some kind of soil. The inside, very interestingly, is a tetragonal crystal formation of water ice called Ice 6.
Oh, yeah.
Which reminds me of Kurt Vonnegut's Slaughterhouse 5 or something, which has the Ice 9 in it. That it's basically touches any water and it crystallizes any water at room temperature. And eventually, of course, someone gets careless and they crystallize all the water on the Earth. Science fiction, though. Don't go.
Well, here, Jerry. Here's Ice 9 right here.
Yeah, that has properties, but that's well below room temperature. So Kurt Vonnegut had it operate way above. Some of these ice is a very interesting compound. Some of these ices are, if you can keep them at the right temperature and the right pressure, they're much, much harder and ductile than the steel. So they actually are a structural component.
So you build igloos out of them, huh?
If you what? Make igloos?
You can build
yes.
igloos out of them.
Yeah, you have ice I-beams and rivets. So
Does it have anything to do with the pressure of being under thousands of miles of ocean?
yes, it does.
Okay. Are there
one of the axes there on that diagram was pressure.
okay, but that leads one to question: is there an Ice 3, 4, Ice 5, ice different levels?
Yeah.
9 is the most solid.
15.
15.
There's ice 11, orthorhombic ice. Yeah. So
makes me question, gentlemen, whether
complicated diagram.
whether if we had ice cubes of Ice 6 or Ice 9, would they float or would it be heavier than water and go to the bottom, like our
I
ice?
couldn't answer that.
Supposedly-
The room pressure one is the bottom of the picture, 1 Pascal.
Yeah, I don't know.
One bar. Going right through the middle. The red line right through the middle. Yeah, freezing point at 1 atmosphere. So that's Earth's surface pressure.
Okay.
So by just lowering temperature or raising temperature, you move right or left across that line.
Huh. Okay.
Okay, let's go back to Titan.
All right. Here's what I got online from different moons around Saturn, mostly inside, I guess, Titan. Tethys, Dione. Dione's magnitude, 10? And Tethys, they sit in a neat line to the east. The farthest out, Enceladus is a dim magnitude 12. This is if you're going to go look. Can you guys see the moons? Well, you might be able to see the brighter ones, I guess, the Titan, right?
You can see a magnitude 9, 10, all that stuff. That's easily visible in like a 6 or 8 inch telescope.
Okay.
And as a matter of fact, you can see to magnitude 13 under dark skies with a 6 inch telescope. So you would be able to see all of these moons. Titan is the most easy to spot as a moon because its color and its brightness. The other ones are like stars. You'd have to watch them over a period of days and see them move to know where they are. This picture is from Cassini, and it shows Titan behind the ring structure of Saturn.
Yeah.
And it shows one of the inner smaller moons, maybe Mimas, up there with the cursor going around it. Next picture. Next, there. Oh yeah, well, wait, go back. There, so it has a hydrous silicate core, silicon, SiH in various combinations as the core of the planet. It's a solid. These does have surfaces, interfaces. The surface of the planet is out there. Normal ice makes up the surface. And the boulders, as you'll see in one of the last pictures down there, if you go down to the one that's real vertical, keep going down there. This is the only picture taken from the surface of an object farther away than Mars. So this was taken with the lander on Titan. Those boulders you see in the foreground, those are made of water ice.
Wow.
It's very cold on Titan.
Yeah, I would imagine. And
I think it was like minus 280 degrees Celsius. So it was pretty cold.
Yeah,
No,
something
it can't
like
be that
that.
cold. It must be Fahrenheit, minus 280 Fahrenheit.
I don't recall that phenomenon happening on Earth, ice arranging itself in rock-like balls. They're either
Well, it didn't form in rock-like balls. These things it's been collided with. So there's active geologic features going on there because of the tidal forces from Saturn. Things have hit it and smashed the surface up into boulders that it looks like they're all rounded. So there must be some liquid feature flowing over them or raining on them. And it does rain on Titan. It rains a combination of methane and ethane.
It comes down liquid?
Yeah, it comes down liquid as a rain.
And
Do you think they sublimate? Do you think they sublimate?
What does that mean?
No, they don't, because they form lakes. So there's a liquid
okay.
phase too. So it's not just vapor and
No, I'm talking about the ice rocks.
the ice rocks.
Sublimate. What do
I
you
think
mean?
it's way too cold to sublimate.
You're going to have to explain that to Tom and myself the other time.
Sublimation is where it goes directly from the solid to the gas
Mhm.
without going through the
exa-
liquid stage.
For example, one time I went on a business trip to Sandia National Labs in New Mexico, and it had been snowing all night in New Mexico. And when I went into the lab in the morning, there was snow, about an inch or two of snow on the ground. And when I came out later in the afternoon, it was all gone, and the soil was not wet. So it had not melted, it had sublimated. The
Okay.
humidity in Mexico, just at least my experience, is that it's very low.
Oh,
Whenever I get off the plane in Albuquerque, I always feel like I'm chapped from head to toe for the whole time I'm there.
most of the
When you come
standard-
up to a doorknob, you've got to hold a key out and then so it can take the spark.
Right.
Oh, is that right?
Oh yeah.
My
Las
experience,
Vegas, same way.
my experience has always been everything east of the Rocky Mountains is just muggy as hell. Isn't New Mexico mostly east of the divide?
No, I don't think so. It's got the Sangre. No, that's
It's
the
part of the
Sangre de
divide.
Cristo Mountains are the southern end of the Rocky Mountains. So
Okay.
if you're in like Taos, you're on the west side of the Rockies. And then the Rockies. So New Mexico is the dividing line. There's a picture also of clouds on Titan. Now the picture was taken, there's three pictures here. And the two on the left were taken of Titan from space by the spacecraft by Cassini. The one on the right is a similar type of cloud shown on Earth. These are in the polar regions of Titan and the polar region of Earth, these noctilucent clouds.
Or for the idiots that call it in, it's a UFO.
Well, if they're idiots and they don't know what it is, then it is for them a UFO.
Jerry, let me go back to something you said a while ago that triggered something. The center part, the core of Titan, is a compound of silicon and hydrogen.
Yeah,
SiC. I've never heard of that. What is that called? Do you know?
HSI, not SiC, hydrous. It's hydrogen and silicon.
Okay, is it a metal? Is it a sandy powder?
That I don't know the physical properties of it. I couldn't answer that, but I would say that most hydrous materials are held mechanically in a lattice structure. So I would say the silicon probably forms a lattice structure, and the hydrous stuff is held mechanically in that structure. That would be my guess, and purely a guess.
There are some elements that really bond a lot. Oxygen obviously is one, and carbon is another, and hydrogen. There are some elements, helium, for example, that don't bond with anything. They're just totally inert or
They
whatever.
do bond, but they're very inert. You can get, for example, the most let's see, the most reactive is fluorine, and the least reactive, I think, is helium. And you
Chlorine.
can chlorine.
Yeah, yeah.
No, fluorine is more. Fluorine is
fluorine.
more
I
active.
thought you said chlorine. I'm sorry.
No, fluorine.
Okay.
And it was difficult to do, but as I recall, a helium fluoride molecule was once made.
Okay. But is that the element that's used in fluoridating our water, or is that a word even?
Yeah, it's fluoride it's not the atom that's there, and I don't know the chemical they use. But
Okay.
yeah,
Sounds like chlorine.
the
And
teeth
chlorine.
pick up fluorine and it strengthens your enamel. So the
Fluorine is-
last picture down there is a proposed project to explore Titan with a spacecraft that sets up a balloon as the probe. It doesn't land on the planet necessarily, but it floats in the atmosphere.
Wow. Have we done that anywhere yet?
Not yet, but we have plans for it in several different places. It's definitely planned for Venus because
Okay.
the acidic part of the clouds is the low density, the lower levels, which are more dense. And above that, there's a relatively benign layer that we could float a balloon in to go around, a dirigible or something, to go around with instruments and map the surface with radar. It's planned for Titan because of its dense atmosphere. And it has been discussed of putting it on Jupiter or Saturn. And also it's been discussed as putting it on Mars, but that would be very much more problematic because Mars has such a thin atmosphere, it may not support a balloon. It is supporting that helicopter, Huygens, was it Huygens?
No, that's the probe on Titan. The helicopter is, what is it called? Perseverance? No, that's
Perseverance. Right.
no, that's the lander.
Ingenuity.
That's the rover.
Oh.
Ingenuity. Yeah. So that's having difficulty flying lately because as the season changes on Mars, the atmosphere becomes thinner and it's harder for the thing to get lift. So
Do you guys remember the late Julian Knott?
yeah.
Yes.
He would have been, I think he was involved with planning for this because that was his expertise. I used to have him on my radio show as a guest. The man was a balloonist. Boy, did he do his balloons. He knew his balloons. In fact, that's what killed him.
Yeah, that's what I hear.
The gondola landed somewhere in San Diego County and rolled with him in it.
Yeah.
But he was a member of the club, wasn't he?
Yes.
One time, Julian Knott. I heard he was working with NASA on those things.
Yeah.
Question that comes to mind real quick is I don't think we have time really to talk about the asteroids Harmonia and Julia, unless you want to do it for 5 minutes. But
What would you like to talk about?
I just had a question about Venus.
Oh,
if,
sure.
If the balloon is going to be in the high upper reaches of the Venusian atmosphere, it's not as hot up there. It's not 800, 900 degrees
No,
Fahrenheit.
that's a surface temperature.
Oh, okay. Well, we could probably cruise up there, so people would be in those balloons.
Well, I guess that's technically possible. I wouldn't want to be there because if the balloon let go, then you're going to be dipped in acid and heat. It's a horrible way to go.
It's worse acid than our acid rain on the planet
Oh,
here.
yeah. I think the what is it? I lost that train of thought.
Well,
But
it'll come back to you and just spout it out when it does.
later. What was that picture you almost centered on? A balloon mission? Oh, I see. Wait a minute. I got to clear my screen here. Oh, yeah. Yeah, there's a concept, almost science fiction, of a place on Mars or on Venus where you are in these balloons.
Wow. It's something
I don't know why they'd want to do it. It's kind of like, for me, a cruise ship. A cruise ship is like being locked up in a hotel for a couple months or a couple weeks or something, except that
surrounded by stores that they want you to buy things in.
Yeah. except that in a hotel, you can't sink.
I'll leave it up to you gentlemen. We only have a couple minutes, but apparently we've been talking a lot about asteroids lately, and there were two that you sent to us.
Yeah.
I got the impression there were three, but I could only see two. 40 Harmonia, about 66 miles across, and the other is asteroid 89 Julia, which is 90 miles across. They're both in the asteroid belt. And you want to save that topic for a later program next week, perhaps?
Yeah, when I put these in there because Chuck is really well acquainted with our asteroid cousins, and these come from different families of asteroids. And I don't know that part of it. So that would be better discussed by Chuck next week.
Sure.
So we'll tack this on again.
We'll call him away from his driveway, polishing his new Tesla.
Yeah. Let me tell you that I just received, we're remodeling our backyard, our garden behind our house, a very small backyard. But I did get permission to put in a roll-off roof observatory. And I'm finishing my 18-inch telescope to put in it. And with the permanent pier that we're going to concrete into the backyard just arrived yesterday. So I got 2 more parts coming from the machine shop, and then we're ready to start building everything.
Well, is that pier going to be surface mounted on the concrete, or is it going to go down into the soil?
No, there's instructions for digging a 36-inch hole underneath of it with a upside down mushroom shaped cavity to fill with concrete. And then there's 4 bolts in the top, and then the pier sits on the bolts and you bolt it down.
Sounds like a great topic to talk about in the future. But if I were you, I'd talk to the president of the homeowners association where you live.
Yeah, I'll give him a ring. By the way, we're having a annual meeting this coming Thursday. And so there's 10 people running this time, or 9 actually. So I may not even be on the board. So let alone president.
Bad as the 2022 elections next year, man, God.
Yeah.
Or council downtown here, they're even coming to my door. Fascinating. Well, you did good, gentlemen. We're down to the wire. We'll go find out if they launched Landsat 2.
Yeah, they did.
They did. Landsat 9, excuse me. And next week, if we get Chuck back, why don't you just not even bother resending that unless you want to, Mr. President, since we all got it.
I'll clip it on the end of the next week's talking points. Let me make a comment about Landsat. Landsat was the first real big imaging platform that went up there in the 60s. It's fairly low resolution, and nobody really is interested in doing it, but it's a law that you have to continue. It's called the Landsat Continuation Mission. And you have to keep putting up these satellites. So there's always one running up there, and they have to be exactly the same spectral bands and exactly the same resolution. So they're backward compatible. And the reason for this is because that Landsat images have become the staple of financial institutions. They can fly over Iowa and they can take pictures of the corn crop, and they can tell from the spectral look, the color, and the spectra of the crop whether it's going to be a good year or a bad year. And so they speculate on commodities that way. And if you want a Landsat picture, you can call them up and tell them the coordinates you want. And it's $50,000. It used to be about 20 years ago to get a frame taken. Now that's nothing for these financial institutions. So they're always directing it and collecting them. And they're trying to make a business out of it. But nobody's interested in taking that over because the Congress and everybody else gets these Landsat pictures of famous features and they hand them out for free. So there's no market to sell them because they're so easy to obtain. So it's a very interesting set of contracts that are out there and continuing. So if you want to speculate in commodities, you need to get yourself a Landsat account.
Well, I would imagine you might have had something to do with it out there on Hollister Avenue back in that time period.
Actually, it's 1960s technology almost. The technology has improved, but the resolution hasn't. And so it was started before I got out of school, and it continues now.
So this is the second one or the 10th one up there?
Oh, they're supposed to keep them going forever. I don't know what it is. It's somewhere up there like that.
All right.
Well,
Well, I can't-
Landsat 9, so the ninth one
Yeah.
just went up, I guess.
Yeah.
Oh, okay. It's 9, not 10. Yeah, we'll go then. That's the 2000th launch for Vandenberg Space Force Base.
Yeah.
Gotta get used to saying that. Gentlemen, thank you. Take care of yourselves and your wives. Get your third shot and stay cool. And come rev your car and take me for a ride sometime, Mr. President.
Okay.
That's number
When do we go
31.
back to judge for yourself?
Oh, yeah, that's right. Sooner or later. This is just like those meetings we used to have. Thanks, guys. We'll see you next week.
Okay.
Our
Good night.
Astro Hour.
Bye.
Good night.
See ya.